Hi, I'm Chem's best friend. If you need any chemistry help, the information is on the bottom of your screen. So hello, welcome back, and are you ready to learn more about calorimetry? In my previous video, we learned about very simple calorimetry calculations, like what happens when you put metal in water, a hot metal in water. That was very easy. We defined system as our metal and surroundings as water, and we did energy heat transfer calculations. But what if it is not a metal, but a chemical reaction? Let's make things a little bit harder today. Are you ready? Okay, so here is a problem. Here's a chemical reaction now in front of us. And the question is, if I have, so it's a single replacement reaction, you're going to put solid zinc into a solution of hydrochloric acid, right? And it will seem like zinc will disappear. If zinc is your limiting reactant, zinc will disappear and you will have bubbles, and then you will have solution of zinc chloride left. And the question is, what's the heat? How much heat is involved? This reaction will actually feel warm. If you put your hand on the test tube, it will feel warm. So how much heat is released? How do we calculate that? So let's go. So when we have 0.103 grams of zinc, and we're going to plunge it into enough hydrochloric acid to make 50 milliliters of my solution in a coffee cup calorimeter, all of the zinc reacts and it rises the temperature of a solution from 22.5 degrees C to 23.7. We want to find enthalpy, which is heat at constant pressure. Yes, we want to find enthalpy of this reaction as it's written. That means what happens when 1 mole of zinc reacts with 2 moles of hydrochloric acid. We're going to use the density of water as density of our solution because it is really probably like mostly water, and we're going to use 4.184 grams per joule per degree C as the specific heat capacity of that solution, which is again almost all water. Okay, how do we approach this problem? Well, we're going to see what's similar from what we learned before. So before we had this metal, and hot metal lost heat, and it was cold water, and water gained heat. Right now we're going to we don't have a metal, but our chemical reaction. So the chemical equation that we wrote is going to be our system. So the reaction is the system, and the water, all the AQ, is my surroundings. The solution, all the AQ stuff, is my surroundings. Is this making sense? I hope so. So let's write this down. We're going to use the same thinking like we did before. So let's write this down. So again, we have heat lost by system has to be that same heat. Oops, this same heat. I wanted to write Q already. Heat gained by surroundings. And remember, lost and gain are opposites. So I need a big negative sign in front of one of these sides. So I'm going to have this. So I'm going to say my system is my reaction, my chemical reaction, and make this as your definition when you solve chemistry problems. Your system is your chemical reaction. The water it swims in, that's your surroundings. The solution, yes, it swims in. So I'm going to say the water that it swims in, or you can say your solution that things swim in is your surroundings. Okay, so let's quickly write. My previous video I wrote, let's write then system and surroundings. What do we know? So let's write all things we know about water, and let's write all the things we know about our reaction. Now this is heat, remember? Heat is Q. What's Q? mass, specific heat, delta T, right? So let's write all these things. So do I have mass, specific heat, T initial, T final? Let's write down. Now for my reaction, mass, specific heat, T initial, T final. All right, what's going on with my water, my solution? Well, we said we have 50 mils. Remember the density, yes, we're going to use 1 gram per mil. So the mass of my water or solution, we will say 50.0 grams, right? Specific heat, 4.184 joules per gram per degree C. What was my initial? Well, it was 22.5 degrees C. And what's my final? 23.7 degrees C. Now, for this reaction, I know mass of zinc. What's the mass of HCl? I need to know specific heats of my whole solution. Well, basically, this is just like one big question mark. This is too hard for me to deal with, right? This is way too hard for me to deal with right now. So how will I calculate that heat of a reaction? But wait a minute. It's the same amount. Heat is heat. If I calculate this side of my surroundings, heat gained, that this reaction must have lost that same amount of heat. I don't need to know this all, right? So let's do that. So heat lost by my system, I'm going to say, keep going, and I'm going to say that is a question mark. That's my Q. That's my question mark. But heat gained by surroundings, that's my water, MC delta T. And what is the mass? Well, I have 50 grams of water. What's my specific heat? 4.184 joules per gram per degree C times what's my delta T? T final minus T initial, 23.7 minus 22.5. Let's close this, degree C. So my units nicely cancel out, grams, grams, degree C, degree C. I'm left with joules. And I'm going to say, this is 251.04 joules. And this is how much heat was gained by surroundings. So my reaction lost. So this is going to be the same number, but negative sign, 251.04 joules. Okay. So this is, it was released, right? So this is, I'm going to say this is heat is released. So that means it's exothermic, yes? And this is why exothermic reactions will feel warm, because this heat is absorbed by surroundings. And when you touch the test tube, your hand is the surroundings. You are absorbing heat. It feels warm. Okay, so, but we are not done yet. This is how much heat was released when, well, that's right, this is minus 251.04 joules is released when 0.103 grams of zinc react, yes? But look at our reaction. Reaction is, here is my zinc, and this is one what? 1 mole. Right? When 1 mole of zinc reacts with hydrochloric acid, with 2 moles of hydrochloric acid, how much heat is released? So but here we only know how much heat is released when 0.103 grams. So this is how much heat is released when 0.103 grams. So let's change these grams to moles. So this is times, we're going to molar mass of zinc, periodic table, right? 65.38 grams of zinc per 1 mole of zinc, yes? And so that means my grams of zinc cancel out. I'm going to have joules per mole, which is what I want. I'm going to have a negative 159,349 joules. Okay. Per mole. Let's look at our sig figs, and we used 3 sig figs for 50. So 3 sig figs, so I'm going to say it's negative 159, and let's make this kilojoules. change joules to kilojoules. So 159 kilojoules per mole. So if I go back, this reaction then, as written, what's delta H? It's negative 159 kilojoules as written for this reaction. All right? So that's how you're going to deal with these problems. Just keep in mind, imagine your reaction is that metal block. This is here, and you're going to treat it just the same. Half of it you will not be able to do, but it's okay, so you'll be able to do the other half, your surroundings, your solution. You will know all the information you need to do it. Okay? So go and try some problems on your own, probably that you have for homework, and see you next time.